Welcome to the topic 1.2 C programming, problem scope and program layout. In the series frequently asked interview questions. I am Prabhunath. Before we start, let us have few questions to be answered. Is problem solving difficult or problem solving using C difficult? Will the C program be confined to a single function within a single file, or it can span multiple functions across multiple files? We shall see that. Will the C code or the entire code of a program access the entire data of the program? Will there be a free will for the C code to access the entire data defined in the program? Right. First question, is problem solving difficult or problem solving using C difficult? Let us see the classification of the problems. Here we have identified two problems. One is finding the LCM and one is inserting a character in a string, right? So first is finding LCM. Here you should first know how to solve this on paper, and then you can apply the C semantics to solve this problem. But in this case, the solving on paper is very obvious, but you need to apply the C semantics to solve this problem. So solving problem is two-pronged skills. One, first you should have the ability to solve the problem on paper. Next, you need to see what is the best C semantics or C constructs you can use to solve that problem in a C program. Right? This is how we can classify. Next, will the C program be confined to a single function within a single file? No and never. Any decent project will span multiple functions across multiple files. We have taken an example of a mathematical operation where I have one main function in main.c and I have one more C file called mathops where I have defined two functions, right? This main function will invoke the functions in the other file mathops.c, and the functions are add and subtract. So here in the main function add is been invoked and subtraction is been invoked, right? And we also have a prototype here to say that these functions are being defined in some other file. This is only for the compiler to ensure that it will do a type checking. So now how do we build this application? Now I am naming this application as app, and again I am using a GCC, and we are using main.c and mathops.c. So now an app executable is generated which contains all the three functions, right? This is how a project is being built, which is spanning more than one function across more than one file, right? Next, can any part of the code access all the data of the program? Never. Any code cannot have a free will to access all the data. There are some restrictions. And will C standard provide any semantics to control access to the data? Yes. The semantics comes in the form of storage class specifiers. So the language will provide some specifiers for the compiler to store data in such a way that it will restrict certain code to access only certain data. So we shall see in detail what are those storage class specifiers provided by C semantics, and how will the compiler and OS, in particular kernel, support this semantics. Yes, a compiler will also support the specification of C semantics, and we will see later how the compiler supports this. Okay, the first specifier. So here the position of the data itself will indicate that the code within this function only can access this data. Also, there is a specifier provided by C semantics called auto. It's not required to specify the auto. Without this, the positioning within the function itself is enough for the compiler to construe that the data defined here can only be accessed by this code. Why the compiler should know? Because the compiler is the one who is generating the instructions for this statement, right? And he has to place this data in such a way that only this code can access. That is why there is a specification called storage class specification called auto, indicates the compiler where to store this data, right? Needless to say, it is not mandatory to use auto for all the local variables, right? And along with the scope, the storage class specifier also indicates about the lifetime of the variable, the longevity of the variable, when it will born, when it will die, right? So in this case, the lifetime is within a function. That means when a function is invoked, when the main is invoked, only then these values get initialized, and the moment the main exits, these values will not be valid, right? So this is the first storage class specifier we will be seeing. Next, register variables. Also, the C semantics provides a specifier called register, indicating to the compiler that the programmer is interested in having this data within the register, because usually the reason for the programmer to have register as a storage class specifier is that data or variable will be heavily used within a function, right? And it is not mandatory that compiler has to fish out some register to be stored, some register to store this data, because it depends on the processor architecture. There is a one-to-one binding, tight coupling between the compiler and the processor architecture for which the compiler generates the code, and it depends on the number of registers that the processor provides for computations, or right? So based on that availability of register, compiler will ensure that this variable or this data is available in that register. If the register is not available, by default this will be stored in the stack, right? So all local variables will get its storage space in the stack. Next, function static symbol. Okay, in here we have used a function static symbol. There is a static storage class specifier. Also, we have juxtaposed a program where it is only using local variable. We want the audience to experiment this and find out the effect of using function static symbol. Again, the scope will be within the function. Only this code can access this data. But what about lifetime? It is throughout the program. Now compiler has to ensure that it should place this data in such a way that only this code will access, and the value will be retained across function executions. That means the value, the longevity is there throughout the program execution. Next, we have file static symbol, such that the specifier, if it is used for a symbol which is defined above the functions, it is called file static symbol. The scope is available for all the functions within this program. Mind you, all these functions belong to same function. Because of space we have written it here, but all three functions are part of the same file average.c. This symbol can be accessed by all the three functions only within this file, right? Any other file which ought to be a part of the program cannot access this symbol called total, right? And the functions are very much self-explanatory. It is to show that this total, without any declaration within the function, can directly use this symbol. And the scope is again within the function of the file, and the lifetime is throughout the program. Next, so code with global variable, right? So this here total, we have not used, there is no specifier to tell that it is a global variable. Without any specifier above all the functions, if any, or outside the function, if any symbol is defined, that is global, right? We don't expect anything such as globe provided by the C standard, right? And how this symbol can be used in some other file, right? Because if you don't declare anything like this, the compiler, when it compiles the C file, will say that total is undeclared. So we have to give an hint to the compiler saying that this symbol is defined outside the scope of this file, right? So this is only applicable for global symbol, right, indicating that this variable is defined outside, and we can the program or the function within this C file can use this symbol, right? So the scope is, it can, this total we can access by all the functions in the program in any file. So lifetime, of course, it will be throughout the program. So we have used total in all the three files, in all the three programs, right? Declaring it only once here, and using it in some other file using extern, right? So storage space is only allocated once by the compiler, and when you sees the extern, right, it also tells the compiler not to allocate storage space in the compiled object file, right? Because compiler also should allocate 4 bytes in the compiled object file or a relocatable object file, right? This is how it is built. This is C minus O test being executable, test1.c and test_2.c, right? Next, okay, the storage class specifiers will indicate 2 properties of the data. One is scope, one is lifetime of the data. So what is scope and what is lifetime of a data? Scope of a data is nothing but the part of the code which can access the data, right? The code which can access the data, right? And the lifetime of the data will be the duration of the data available in the memory. So what is the longevity of that data? So in a nutshell, we have brought about this chart to make it easy for you to see the complete picture in one chart. See here, if the storage class specifier is auto, then which is only defined within a function or within a block, right? I will leave it for the audience to find out what is this block. This block usually will be a block within flower braces, and we also have a that also is defined as a scope, right? The storage space is stack, the compiler organizes, underline the word organizes, the data of the local symbols in the stack, organizes to store the data in the stack. How, we will see later. The scope, again within the block where it is defined or within the function. Lifetime, again within the function and within a block. So its lifetime starts when the function is invoked and ends when at the exit of the function. So register, again the same thing, but the storage space will be maybe processor registers. I am using the word may because not guaranteed always. So again, static, we have a function static and a file static, and the storage space is data section built by the compiler within the object file, and the scope is again within the function or a block where it is defined, and all the for a file static it is all the functions within the same C file. Again lifetime throughout the program. So the value is initiated at the time of initiation of execution when you give a /app or a.out. So the value will be there throughout the throughout the program. External. So you usually defined outside the function, or it can also be used within a function. Storage space. When you use external, right, that file will not have a storage for that variable because that is you defined somewhere else. So functions within the same file. When you use external, right, that means the scope is within that C file. We can also use external within a function also. In that case, the scope will be only within that function. So lifetime, it's throughout the program. So I want the fresh engineers who are new to C to experiment all these data. I mean, you have to use all the data within a function, outside the function, and use with this storage class specifiers and experiment out and see what is the effect of specifying a storage class for a data. Next, what is the support we get from the compiler? So for defining a scope, for complying to the scope, right, the compiler at the time of generating an object file, it will maintain the local symbol tables for every function, right, so that it can refer this symbol table while generating the code for that function, right. Also it will generate a file symbol table. In the local symbol tables, you will only have symbols defined within a function, right. For every function it builds a symbol table storing all the symbols of that function, and it refers that symbol table for generating the assembly code. But here in the file symbol table, it will store all static, file static, function static, and global symbols, right. When a relocatable object file or a compiled object file is generated, these symbol tables will not be retained because its job will be over once the compiler generates the code for that function. But it will retain this file symbol table because it is also an input to the linker, right, to know what is the scope of a symbol, right. So because the reason you will understand in the next slide. So how does the compiler ensure the lifetime is guaranteed for a particular data based on the semantics? So all global and static data within a C file will be in the data section. So in the object file, I am just saying for a.c file, so compiler will just generate an object file or compiled object file called a.o. Within that file, you will have data section where all the data is stored, global and static data, and all the code is stored in that function, right? So since all the global and static data is there within a C file, the linker, when it has to generate an executable object file by combining all the data sections of a compiled object file, linker has to distinguish between global and static. Only way he will do is by looking at the symbol table. Hence the compiler will retain the symbol table for the use of linker. So how does linker support? Linker just have to combine all the data sections of the compiled object files which is part of the program. Suppose if I have two files to be part of a program, A.C and B.C, the compiler will generate A.O and B.O, and the linker job is to combine the data sections to make it one big data segment, right? Now this data segment will contain the global and static data within a C program spanning one or more files. If I have A.O, B.O, when it combines the data section of A.O and B.O, then it will have the symbols which is defined in A.C and B.C, and finally generate A.out. So it's an executable object file, executable, which can be executed. You can give ./A.out. Now what is the support given by the kernel? Again, kernel will have to just use the code segment, data segment which is provided by the linker here, right? And also it allocates stack to store local symbols. But surprisingly, I have not mentioned stack here. The compiler, is it not storing the local symbols within the stack? No. If you remember in the earlier slides, I told compiler organizes to store the content in the stack, right? So, and why it is not stored in this compiled object file? It is for the listeners to think, ponder about before we address this in the coming sessions, right? And certainly there is a space for stack in the memory while executing. So when it comes to kernel, it's all about execution time concern, right? When the code is executed ./A.out, right, after that the kernel has to allocate memory to house the code, allocate memory to house the data, allocate memory to house the stack, allocate memory to heap. That is dynamically allocated memory, right? So more on this we will be discussing in the coming sessions, right? For now we should understand that this is the support given by the kernel to ensure that the data, they ensure that the lifetime is taken care of all the data symbols, right, by having placed the data in the data section and by placing the allocating memory to house the local symbols of all the functions. So how it is guaranteed the lifetime, we will see in the coming sessions. Next, yes, after this session let us try to answer these questions. Can you extern a file static symbol? That means, can you apply an extern for a file static symbol? Right? I just want you to experiment and figure out and reason it out why it can't from a design perspective. If you want to provide a language, is it viable? And normally this is what we have seen. People have a habit of including a C file within a C file, right? Instead of compiling separately, they include a C file within a C file so that only one C file they will build. what is the side effect of this. This is a very important thing for you to understand, and this is very much within the scope of within the ambit of the storage class specifiers. So I want you to ponder over this, and we will discuss this in the coming sessions, right? And here we are coming to an end of this session, and food for thought before we come back for in the next session. Can you solve these problems? I just want you to solve it on paper, not just go blindly type and get the answer and then ponder about it, right? So just a simple comparison: 1 greater than -1, a greater than -6, and see what is the result, right? Few more things: float equal to 0.25, and see what the result is, and here what is the result. And all I want you to experiment on 32-bit machine initially, right? So 32-bit compiler to be precise, and figure out the answers. We will be discussing about this. What is the fundamental reasoning behind discrepancies in the answers? What if ever you find here, right? So with that, we will be concluding this session. For more videos, as and when we release it, if you want to be updated, stay tuned on this channel. So I wish you subscribe to this channel Gyan Ganga to be notified about our future videos. Thank you.